I am Vaughn Stewart. I am the Chief Evangelist for Pure Storage. I know many of you from many years within the IT industry, and I appreciate all of you coming out to visit us. And for those of you that I don't know, I'd like to take some time later on this evening to maybe build a little rapport. And for all those that are online, thanks for sticking with us. Amazingly, we are right on time. We started 15 minutes late, and Neil ended like literally right on time.
John.
We got a chair switch going on. So what I'd like to do in the remaining 40 minutes of our time is to share with you some thoughts and some feedback around asking the right questions. Right? You've heard this theme that Matt set up when we opened the conversation, and Neil kind of touched base on it towards the end of his conversation, which is so often as engineers we want to ask engineering-based questions. Do you scale up or do you scale out? How many IOPS can the box achieve, right? What's the raw price per gigabyte? These are all fact-based questions, but have little to do with implementation, and yet sometimes we hang on them. So we want to focus and give you some data points if we set up what we think are more substantive questions. And these data points will go through and touch base on some topics that extend beyond some of the architectural elements that Neil touched base on and go into the application usability space. So for example, if we look at an area like simplicity, we know from our history that when we look at in our data centers, right, there's basically a single kind of simple stack, if you will, vertical picture in your mind between an application, the compute layer that it runs on, the networking interconnects, right, both outbound for the end user access and inbound for the storage networking, and then the storage device. And we typically have to take application requirements, configure that to the resources from the layers below, from the infrastructure, right? So as we move forward with flash storage, how does it drive simplicity? How does it change the model for the storage element within that equation? And we have this design goal, which is we want to make storage invisible. We feel the best infrastructure is the one that you don't have to touch. So let's look at that through a couple of ways. So first is, when you adopt flash, one of the first kind of, at least from a pure storage perspective, one of the first kind of surprises for many storage admins is the understanding that they don't have to do anything from a traditional storage provisioning perspective. There's no root volume, there's no system volume, there are no aggregates, there are no disk pools, there's no caching tiers, there's no adjusting or assigning between cache and disk types. There's none of this carving out. We've by design tried to make a number of elements within the array adaptive to the use of the array. So when your out-of-the-box experience with a pure storage flash array is as simple as giving it 3 IP addresses and you're up and running. 1 IP address for each physical controller, and 1 logical address, which now represents its virtual address for the entire life cycle of that array. And understand that the array's identity is in software or metadata, not bound to hardware. Very analogous to like a VMware vCenter cluster, if you will. Okay, so allows us to, as Neil touched base, change out the storage architecture. So from a storage admin perspective, your model changes to now I'm just basically monitoring, what's the availability of the system? Am I having any faults? What's the capacity and the utilization of the CPU and the overall storage capacity? Right? I am out of the tuning elements. And if you look at our GUI interface, you'll see that there aren't tunables that are available for you as an administrator. This doesn't mean that in extreme use cases or new use cases where a customer maybe pushes the system into a use that we haven't seen before, that we may not have to go in and tweak the box for some optimization. But anything that we've done with that over time with customers where we've done these lower adjustments, those get brought back into the intelligence and the adaptive nature of the software and come out in a Purity operating system or operating environment release. And again, we'll eliminate that need to make those variable settings. I've been with the company a little bit over a year, and I can state for you firsthand the amount of times that we would have environment variables set in customer arrays till now is almost nil. We've seen this significant enhancement of the adaptability of the array for various workloads. Second is from if I go from the bottom of the stack to the very top of the stack and I look at my application layer, we are used to application admins saying I have a requirement for performance or availability. My database may need this type of characteristic. The logs, for my application requires this other characteristic, etc. And they want to fine grain and carve out storage from underneath the system. What we've even seen is storage array vendors actually give recommendations back up to the application vendors. Neil touched based on fixed block architectures versus variable length like we have. Right? We've seen flash array vendors publish articles say your application would work the best if you'll export it and re-import it to a block size that matches the hardware of the flash array underneath it. We don't believe that that's viable for anyone. We should be able to make the system adapt to the block size of the application, and by having a variable length block, we've been able to accomplish this. You see this in our performance results, and I'll show you some performance numbers in a bit. But this is the goal, is that the application should be able to fit on the infrastructure, and the infrastructure, much like what we're used to in the virtualization space, should be able to adapt. They should be able to throw resources at it and not have to have a change in the application, because for many, as we get into, and particularly when I say many, modern IT being cloud-based infrastructures, many IT departments have no idea what's going on inside of that system. They don't know what the application is, what its block size is, what the read-write patterns are, how the file system's partitioned, etc. So you have to have a more resilient infrastructure. And last but not least, because I've touched base on cloud, is this massive adoption in today's data centers, whether I'm a service provider or an enterprise, which is I need to make it simple and I have to have it to be automated and highly integrated. And so we offer operational management, whether it's GUI-based, command line, or we've recently published an open and programmable set of RESTful APIs. And these RESTful APIs are actually the linchpin, or if you will, that underlay all of our integrations. We've got an OpenStack Cinder driver. We support the VMware's vStorage APIs for array integration. We have a vCenter plugin. We now support Log Insight plugin as well as a Microsoft VSS provider. We also have supporting under the RESTful API. We've released a Microsoft PowerShell toolkit for the array, as well as a Python automation toolkit. So again, we're looking at really investing in RESTful API as being the standard framework for us. I touched base on the Cinder driver. We did just make announcements last week, and so I want to touch base here about our significant increase in investments with OpenStack. Pure Storage has recently joined the OpenStack Foundation as both a corporate sponsor and a code contributor. So with the Juno release, which was October 16th, we released our updated Cinder driver. So Cinder, for those of you who are not familiar with OpenStack, is a block-based storage driver that takes the provisioning calls within OpenStack and allows it to translate down to provisioning calls on the storage device itself. So this is a significant update in our Cinder driver. The last one that we had released was with Folsom roughly at the fall of 2012. So it was about a 24-month update within the Cinder driver. This allows for volume and snapshot commands to be executed within OpenStack. It's create, delete, expand, clone.
So how will that work going forward then, Vaughan? OpenStack releases a rapid clip every 6 months, whatever. Will that driver natively support the next release of OpenStack, or are you looking to be every 2 years you'll support every fourth release or whatever it is?
Yeah, great question, Nigel. So our increase in investments in OpenStack is so that we can continue to drive investments in that space. I think it's fair to say that when we released our driver 2 years ago, that was to address some customers that wanted OpenStack integration. The market momentum for OpenStack wasn't there, nor were we in a position in terms of making engineering investments where OpenStack had the highest return for us. If you look at how we've grown over 2 years, right, just with the last 2 rounds of funding, for example, it was much more critical for us to do integrations with our large partners, the ones that provided us the largest market opportunity. That was primarily in the areas of like Microsoft, VMware, right, partnering for solutions around Oracle database, Cisco systems. This allowed us to grab market momentum. Now that we've established ourselves in market, while we are still a private company, we are a large, small size company, if you will. The OpenStack momentum in market, I don't know if you guys are seeing the data from the OpenStack Summit, right? Significant year-over-year growth within their space. It aligns well with us, and so now we're investing. And this is also mapping to some of our customer demands, frankly.
Yeah, we see this pretty linked to the replatforming that we see happening. I mean, customers are basically coming to us saying, we want to set up a new environment. It's going to be based on Flash, and it's going to have a new OpenStack setup around it. And surprisingly, large bank type customers, but also surprisingly traditional customers are thinking this way. So I've really been shocked by the momentum.
Yeah, and if you look at most markets as well, there's usually like 2 top tier vendors that occupy any position, right? If I say the database, space, you say Oracle and SQL. If I say operating system, you say Windows and Linux, right? If I say hypervisors, you're probably going to say VMware followed by maybe Hyper-V, correct? So when you get into this cloud automation element, there's OpenStack and who's second tier, right? That they're the Robin to the Batman, if you will, has yet to be defined. But when you look at the OpenStack community, I mean, VMware's got a distribution, Red Hat, Cisco, EMC, Hewlett-Packard, right? I mean, it's clear that the IT industry as a whole is going to invest in OpenStack, and so we have to make sure that we support this because we think this is going to be the leader in that space. Who the alternative will be is I think yet to be determined.
So,
to your question, which I got off of.
Okay.
So the current driver today is shipping in the Juno release. It will support Icehouse, so it is backwards compatible. We will look to ship a new driver either as more features are available through the OpenStack framework, whether it's Cinder or whether these drivers and enhancements come in areas like Heat or Glance, etc. Second, so we will update the driver as we need to based on released feature sets or bug fixes. We also have our driver available on GitHub and in our communities because we do plan to do interim updates in between the OpenStack releases so that we can continue to enhance and refine our driver. In addition, and partnering with the driver, we released what's called the Python Automation Toolkit, also found on GitHub and in our communities. This toolkit allows us to extend a set of scripts, again, based on RESTful API, and leveraging Python, which is a native scripting language found in almost every flavor of Linux, right? And it's also deeply entrenched within the OpenStack stack, that allows us to extend additional data management capabilities, such as snapshot replication and archiving, schedules, capacity and performance reporting back to the OpenStack framework that frankly is beyond the scope of Cinder today. It might get there over time, but so this allows us to add a complement of services in a very canned manner. And we will continue to build this toolkit just like we build our Microsoft PowerShell toolkit for the Windows world. And again, these all work under the hood with a RESTful set of APIs, which we've have available that anyone can program to if you want to build tools beyond what we're making. Fair? Okay. So I want to show you a couple of demos here, and I want to do this just in case we run out of time. I figured put the good stuff up front. So the first thing I want to show you is project codename SPAG for single pane of glass. You heard Kix and Neil talk about various states that today we have a two-node controller, right? It's a stateless controller architecture, but we have customers that are buying significant volumes of controllers, and they are looking for a form of federated management, single pane of glass, something that supports role-based access, so I can have delegated, sets of administrative tasks to different operators or arrays that are managed by different folks. So I want to show you a version of our SPAG. This is SaaS-based, so it is hosted as part of our Cloud Assist, which means no on-premise software, no software licensing. This is completely included with the array. Okay, it can be accessed anywhere as long as you can authenticate into the framework. And I want to just caution you, this is on our QA and Dev Ops lab, so this is not what you see in the wild. What you'll see here is a collection of cards brought up in a web interface. This is HTML5, looks the same on every device. This is in a web browser. It's designed to be color-coded so that you can quickly recognize if you need the health of a system and actions you may need to take based on color. Each card represents an array. You can see here, performance, read, write, bandwidth, IOPS, capacity, data reduction ratios. Color coding on the capacities as well as these little squares are color-coded to show you errors that are occurring on the box. That one red box had a failed SSD. This has a cable pulled. And if I need to deep dive into any system, I merely click on it. It launches another tab in my browser. And now I am into the Purity OE Web GUI interface. And I can see what's going on within this system. Right? Rather simple, straightforward, trying to keep that clean line feel and easy visibility and feedback at a glance. We're able to filter this view. I did mention there was role-based access, so you'd only be able to see the systems that you're assigned to, but I can filter this view as well based on model, protocol, release version. I can sort based on whatever type of attribute that I'm looking for within my collection of systems. And if I don't prefer the card view, I can flip to a columnar view, if you will. And again, sort based on whatever type of metric or feedback or resource that I'm looking for. I can do the same thing here in terms of looking at all my messages. These would be system-based messages across the install base. And as well as now I can start to look at behaviors that go cross-array like replications and look at this at a macular level. And this is an early iteration of what we're building here on the replication space.
Is the plan for this to keep it running on your side or give it to the customer as an appliance to run in their environment?
So our support model is radically different than the traditional storage array model. It is SaaS-based, which and it's included within the system. So we allow you to have per unit monitoring within the Purity operating environment itself. It will store back a year's worth of history. It'll allow you to look at your trending, your growth, right? Allow you to do the management and administrative tasks. Your system or all flash arrays report back to Cloud Assist on 30-second intervals. Cloud Assist is where the diagnostics and the error conditioning function occurs within the arrays to allow you to know that there was an error condition on the array, what steps and procedures to take, whether we open a case. It also allows us to keep a complete history, an infinite history of what's going on with that cluster. Again, not associated to the hardware, associated to the virtual identification or persona, if you will, of that system. So you would be able to, as a customer in time, look at a 5, 7, or 10-year trend within that system. How did it grow? What was your capacity? What was your data set usage look like?
So Vaughn, some customers don't allow, cloud access and things like that. What do you do for those kind of customers?
So great question, Ray. We understand that there is a subset of our customer base that doesn't allow to have their systems report back or phone home to the vendor for support. What we released back in the May timeframe of 2014 with part of our Purity 4.0 and the FlashArray 400 platform launch was support for dark sites. We have customers who have dark site requirements, and as such, we provide them a Cloud Assist console that they can deploy on-premise, configure their systems to report back to their central point of contact, and then just the console needs to get updates in terms of its software. And then based on a support need or concern, that customer would then initiate a call back to our support for getting into the level 1, level 2, et cetera type of escalation.
I'd say in general, we've also been pretty positively surprised about the openness to the SaaS model. In general, SaaS has become very common, and the upside of essentially not having to run management infrastructure on your own and not having to have the expense to run management infrastructure has been a real positive selling point of this.
That could be true, but I mean, building on what Ray said, sometimes you really do want to, you have customers that for either sovereign issues or whatever, really require that
And we support
all
both.
the data reside in whatever country that is. And
So we will support both, but we're going to try to lean towards SaaS first because we think it's the right long-term model, and we've been pretty pleased with the customer interest in that.
Yeah, we're running about 2/3 of our install base today with the phone home capabilities to us, and about 1/3 choosing to do the dark site support.
Higher than that, actually.
Okay. Well, the numbers change.
Are partners who sell the stuff going to be able to get a federated view of all the systems that their customers have?
Absolutely. That's one of the cool things in the whole SaaS model is that we can team with our partner channel to help add support capabilities. And so if a customer elects that as an option, then yes, giving access to a partner to be involved in the support experience is another key feature.
Yeah, we've had some of our VARs have different support capabilities, right? They build that in terms of part of their relationship with their customer base, and absolutely can extend it to this model. Great. So any thoughts or feedback on this blog, right? Looks promising, right? It's a nice step forward for multi-array management. You should look for us to hopefully be able to bring this into production into our customer base the first half of next calendar year. Now I want to shift gears a bit. I don't know how I'm doing on my time. I'm hoping I got 20 minutes left. I want to share with you our vVols demo from VMworld. So this is just a few weeks old. So to level set, so vVols provides a significant advancement in storage connectivity to virtual machines, moving away from the large clustered volumes with virtual disks, and almost going backwards to a model where volumes on a storage controller are directly mapped to a virtual machine. vVols is referred to as VM granular storage. I actually tend to look at it as being much broader than this. It's going to unify backup operations. It's going to allow a backup admin, a storage admin, and a VMware infrastructure admin to know when one or the other backs up something, takes a snapshot. It's going to allow performance tools to work, right? I'm not going to always be bound kind of at the hypervisor level with what's going on and hoping that the storage team can figure this out. So let me show you this. This is a little detailed. If some of you have experience with VMware You may be familiar with some of these constructs, and there's a couple of new ones here. So we start within the vSphere web client. This is where we manage our VMware infrastructure. And the first thing we're going to do is we're going to register a Pure Storage VASA provider. Now, VASA providers can run as virtual machines or appliances, or they can run directly on the array. We've chose to make our VASA providers run directly on the array, provide HA availability, and allow us a means to update the VASA provider as you update the Purity code. So again, trying to look for a simplified process for the customer. So we're going through the registration process here. You can now see that we have a Pure Storage VASA provider registered. And again, I want to be clear here. This is pre-release code engineering. Not everything is finalized here. So the first thing I do once I have a VASA provider registered is I have to create what's called a storage container, or connect to a storage container, if you will. But a storage container is basically, think of this in our implementation, is a form of quota. It's a volume of raw capacity that the storage administrator is going to allow the VMware infrastructure to consume. Not all at once, but this is just basically how quota enforcement is, so that you can have a check and balance system. This isn't required by any means, but we get into lots of multi-tenant type of deployments, and we hear about these requirements to share the array and not let just one group take full control, full access to the device. So here's our storage container. You can see here we've got a quote on it of 70 terabytes. And so the first thing we want to do here is, after verifying that this is actually connected to the system, is we're going to take one of our virtual machines that are currently sitting on VMFS. We're going to clone it into a new virtual machine, but this one's going to be powered by vVols. So what vVols are going to do, as we walk through the wizard here, and you see we picked the Pure Storage container, it's a vVol format, is it's going to create a volume for each storage requirement of this virtual machine. By default, each virtual machine requires 3 vVols. One to hold the virtual machine's configuration files, one to hold the vSwap, which is a running state so the hypervisor can handle open provisioning of memory, and the third is to actually make up the first virtual disk connected to the virtual machine. As you can see here, as we're going between the two interfaces, we've cloned this machine, and we see the configuration and the virtual disk of the vVol. That third one will actually be created for the vMswap when I power it on, because that is a dynamic element that the hypervisor is provisioning.
Now, is this actually creating a new volume/LUN for every one of these 3, or is it storing it?
Yeah, so the question was, is this creating a new LUN for each 3? Let me pause on that, because I want to talk about the video, but I will come back to that when we're done here. What you're seeing here is we're going to go ahead and make a snapshot, right? So now in the vVols version 1, the first set of capabilities that VMware is providing for all the vendors is a standardized framework to leverage snapshot cloning of virtual machines for instant provisioning and snapshot backup capabilities. The rest of the functionality available through version 1 will be based on vendor implementations into the vVols open framework, so that you'll have a very unique set of offerings on a vendor-by-vendor basis from the storage perspective. As you can see here, and going to your question that you asked, yes, we are creating a volume for each storage object that's going to allow us to see, and there were stats there on data reduction on a per volume basis, performance on a per volume basis, both throughput as well as I/O size and type.
What's the maximum amount of volumes per array in version 4?
So the question is, what's the maximum amount of volumes on our side? The minimum requirement to be a vVol certified array is to support 10,000 volumes. So if you understand it from that perspective, there is work that all the storage vendors, Pure Storage included, have to do in terms of making reporting, monitoring, and scaling a storage array GUI scalable. Right, today, it's cumbersome if you have a couple hundred volumes. Imagine a couple thousand.
Is that supported in the current release or an upcoming release, that many?
So the vVol requirements of 10,000 is a VMware requirement. We understand that vVols is in beta today. We're looking for a GA sometime around the middle of next year, but that's a VMware shipping date. Our support is targeted to run to be supported right around the release time of GA. I want to get a little soft here, so sorry that I'm starting. It may be within the 90-day window. Maybe it'll be shorter. I'd have to refer back to product management on that, but our goal is to support it rather aggressively as we go through the first half of next year with marketing and other efforts. A couple things that are unique here, that's where this demo ended, is showing you that we've built a system in place. When you delete volumes on the array, we will actually sit on them for 24 hours before we actually delete them, just in case that's an accidental deletion. We look at volumes as usually being directly attached to a virtual machine or an application, so it's kind of a safety mechanism, a buffer spot, if you will. I know there was conversations around garbage collection earlier today. This would obviously lag some of the garbage collection elements.
Is this vVol specific?
This is pure storage specific. We're going to extend it to vVols.
And have customers been asking for this? It's like a pretty cool feature, actually.
I think it's something that we identified early on and brought forward. I don't know exactly the origin.
I think we're all excited about it because it really allows block storage to see VM granular and provide all the services. I think much like any upgrade, it's going to take customers time to get used to it, and there has to be revs on both the storage side and the VMware side. But we're excited to push it in the industry.
Yeah. Now, one thing I want to share with you, what's very unique about Pure Storage, is when you think about a all-flash array, right, the ones that are built from ground up, I'm not talking about retrofitted systems. All-flash arrays from the ground up, by and large, are metadata engines. They are object-oriented storage devices that you are accessing those objects based on SCSI metadata definitions and over SCSI protocols. And so when you think about moving from VMFS to vVols with Pure Storage, will be an in-place upgrade. It may require an upgrade of the Purity operating environment. That is non-disruptive, but it will not require any additional capacity because vVols operate as a storage vMotion migration. And so you'll be migrating and leveraging xcopy copy offload from the VAI primitives to clone a VMDK on VMFS to a vVol on Pure. That'll happen in a matter of seconds, will consume no additional space, and you will have your VMFS and all your snapshot versions for fallback until they roll off based on your scheduler and retention policy. So this is something that we're very excited for on our install bases because they know they can adopt Pure today and know that they're set up for taking the next level of storage integration with VMware tomorrow without making additional investments. Scalability. How am I doing on time, Matt?
Quick time check. We started a little late. What time do you want us to try to finish up?
You have 15 minutes left.
Okay, I'm going to pick up the pace. You guys ready for death by PowerPoint? So scalability. So this kind of goes back to that notion that we were hearing about before. How do you scale the system? Is it scale up? Is it scale out? Right. What we've heard fundamentally, and some of this is going to be repetitive. Customers are looking to purchase storage today that fits within their budget. Right. Obviously, making flash affordable, flash at the price of disk, is something that we are known for. Something that we've pioneered and engineered, and we're bringing the reality of flash to both demanding workloads, but more importantly, just that quality of the sub 1 millisecond latency to all applications. The customers want to start small, and they don't know what they're going to need tomorrow, more performance or more capacity. So we've built a system through the stateless controller architecture that allows them to grow in either direction that they need to. What's been great is to actually go from different hardware controllers non-disruptively and without performance drop from the 300 series through all the models within the 400 series, and we will continue that architecture as we go forward into our next generation of controllers. There's actually been customers who have actually tweeted their hardware upgrade process with controllers, right? So sometimes things sound too good to be true, and then social media steps in and can kind of validate what sounds like big bold marketing claims that you have a hard time believing. So this is only enabled through two elements. The stateless controller architecture, which basically the controllers are CPU, memory, and I/O ports, and that both the data write journal and the persistent layer, which being the NVRAM and the SSDs, are in the shelf. This allows us to mix and match this hardware and move forward. And we've built this business model around it called Forever Flash. So this is an image of today's architecture, flexible, scalable, start where it's affordable and grow over time. I shared with you federated management with the demonstration of the single point of glass, which is not the product name, but the internal project name, if you will. And we are giving you a little bit of a vision and a forward direction statement. Once we've shipped SPOG, we will then shift our engineering efforts into federated scale-out architecture. And so if I were to share with you the state of the market today, is you tend to see what I will call a shared everything scale-out architecture. This is what Neil was referring to when he's talking about growing in increments of 2 nodes and everything shared on the back end. And as such, if you actually lost 2 nodes, you'd lose it all. We don't like the failure domains in that architecture. There's the shared nothing architecture, where you can lose an entire node and not lose any data, but we don't like the high and back end cost of triple mirroring for 5 nines availability in that architecture. This is a logical clustering of 2 node systems that will give you load balance, load placement, allow you to expand the hardware abstraction that we have today across a number of nodes, but give you a single point of management. No questions on time frame for that. That was very interesting. Why not a different architecture?
Wait a minute, you still have two nodes that you're scaling out, though, right?
Yes, but each cluster pair would be independent today. The concept of a scale out is a logical management element, a load balancing element between the nodes, but there is no data striped across those nodes. There is no reliance that if I lost nodes, I'd lose all the data in the pool, and there is no requirement on the back end to have triple copies of the data. So we're trying to balance the economics, right, with reduced failure domains, but also drive the simplicity of greater scale out. Look, we believe wholeheartedly scale out for NAS is a requirement today. Scale out for block storage, by and large, is a management paradigm.
Especially with the use cases for this.
Especially in a virtualized world.
Yeah. Well, virtualized world where I can move workloads non-disruptively. If I look Oracle with ASM, I can move right across storage devices non-disruptively. So now let's talk about another element of scaling, which is performance. Right? There was a lot. This is one of those classic questions where I think storage admins, because they're in the infrastructure space, have to prepare themselves for worst case scenario, and they don't know what questions to ask. So they ask questions like, how many IOPS can your array serve? Right? This is why you see crazy thin synthetic workloads that are designed to find the breaking point of the array, but have nothing to do with their working set. So, it wasn't too long ago in market where 1 million IOPS was the big claim that had storage folks very excited. And we said, that's great, but you show me what application is achieving 1 million 4K IOPS, because when you look at our phone home information, the information sent by our install base through Cloud Assist, and we've bucketized it here based on the size of the I/O, with each vertical line representing 0 to 10, 10 to 20, 20 to 30 in terms of the size of the I/O, K. Right? We have very few that are sub 10K I/O operations. Our average I/O size is 40.6. It's 56 and change for reads, and it's 24 and change for writes. And so what we've done is we've built an adaptive I/O size within the system, which is we never split an incoming data packet into multiple I/Os until it crosses the 32K boundary. This allows us to scale our system significantly greater. And yes, while we don't play in the 4K vanity zone that you see publicized, when you actually look at the zone that we actually have an install base between, we outperform every 8K and 4K fixed block configuration that you see within the market today. So our systems, the 450 provides 200,000, 32K, 100% read IOPS at sub 1 millisecond latency. By contrast, the industry leader in shared scale-out architecture gives you 67,000 of those per brick. So you would need 4 of their bricks to one of our arrays. So again, scale out, scale up is the wrong conversation. It's what is my I/O size, which goes to the next question, which is most people don't know what their I/O size is. If I'm dealing with applications that sit on host file systems or virtual machine file systems, I tend to get the block size of the file system, be it NTFS or VXT3. Sometimes we think, well, the app owner knows, right? The app owner knows that Oracle by default is 8K, or Exchange is 32K, or SQL is 8K. But we forget that applications have multiple I/O streams. Each I/O stream is associated to different tasks. Each task may have single or multiple I/O streams, and they're of different block sizes. So I take something as very simple as a common 8K database. The database entries and reads and writes are 8K, but my log entries are 512 byte, my log shipments are 1 megabyte, and my default query size is 1 megabyte. And if I just do some common mix, I can quickly go from 8K to 48K, and we see this all the time. I haven't even brought up the I/O blender in the hypervisor virtualization space. Right? So again, we think there needs to be an increase in the conversation point, which is you should really be looking at testing your real apps, profiling your real apps, and get away from these 4 and 8K, how hard can I drive an array?
Hey, Vaughn, can you go back to that the distribution chart again? I mean, you mentioned the average was like 56 for write and 42 for something like for read or something like that.
Yeah, 24.
Yeah. What's the median in this sort of scenario? So the median would be somewhere around 21 to 30K kind of number. Is that?
Well, we've to come to 40.6. We gives a little bit of, you can do easy math here, but so 56 is the read and 24 is the write, and then you take the read-write mix, you get to 40.6. So not exactly a median. I'm trying to come to a fair average.
Yeah, I mean, you can see there on the right, that's the population of averages on an array basis, and even within an array, there's an average of a wide range of I/O sizes, right?
Yeah.
Yeah. So our goal was we adapt to an I/O size between 512 byte and 32K before it becomes a second I/O. And so if I look at any size I/O, if I take a 40.6K I/O operation, and I have an 8K system, that's 6 I/O because I have to go just over 5 I/O, and for us it's 2. That directly leads to scaling the system. That's how you take hardware components that are similar, Intel CPUs and SSDs, and you get different results out of them. It's because how are you handling, and I guess I'm going to talk ahead here, how are you handling the writes as they come into the system? A storage array does not control the size of the I/O that the host of the application sends to it. It can only react. And so if I have a fixed metadata architecture, and the example here on the left is one that shows you an 8K DRAM-based fixed metadata architecture. So as the write enters the system has to, the write enters system memory of the controller. As the controller copies from system memory to DRAM, so it's got persistence, and it has to do this before it acknowledges the write, it has to break it up into 8K chunks. And once it's broken up into 8K chunks and it checksums and everything's valid, and it's in DRAM, the DRAM gets mirrored, it then acknowledges the host. We've got the write. Right, that's faster than waiting for everything to get staged down to the persistent tier, whether it's DRAM or NVRAM. Right, this is a common format within the storage architectures. That process, that overhead of breaking up those chunks, checksumming that, and then acknowledging back, versus us allowing us to just do it on a larger scale. So if you're sending me a 512, I can acknowledge 512, no problem. If you send me 40K, I break it to 2 I/O operations. Turns around a faster transaction in terms of end-to-end time for processing that, so that the host is acknowledging faster writing. Now it's only written to both, whether it's DRAM based or on pure storage into our NVRAM base. It's just writing to the write buffers, but it's turning that transaction around faster because of the amount of effort to put into that. Then as we go through the metadata elements within a storage controller, compression and deduplication, and Neil touched base on this. Again, if I'm rigid on fixed blocks, say I get 16K of data, and I reduce it 25% down to 12K. It still has to be written into 2 8K blocks, and I don't get the extra 4K that I didn't use back. It still consumes 16K on flash, because it's just like file systems, right? I can't stick more into the block than that data itself. Whereas if it was 16K reduced to 12, it's just 12, and it goes 12 in the journal, and then right behind it becomes the next write. So we get, even when we start to talk data reduction technologies, we still gain efficiencies because we can layer all the writes back to back versus having to fit into a Tetris style system, if you will, on the back end. These buckets are only one size. Question?
I like this because we do a lot of testing where we measure these block sizes of the applications, and even in SQL Server, officially writes 8K, it does extend, so they're bigger. But even different workloads on SQL Server give you different block sizes on the IOs.
Absolutely.
So you need to be able to test.
Yeah. Thank you, Dennis. I appreciate that. Third-party validation.
We've got about 5 minutes left. Maybe hit the dedupe differences real fast.
Yeah. So I'm going to jump ahead here. So this is my last slide. Look, none of this is possible if we couldn't break the economic barrier of cost. We're very proud that we are in multiple years of sharing what our customers' actual data results or actual results are from data reduction, right? And this is about 2/3 of our install base, because these are the ones that phone home and report back to us. I'm going to share with you just one kind of element here is we share in our deduped or our flash reduce ticker, I almost used the wrong word, right? We're actually reducing data at about 5.5 to 1 across our entire install base. Now obviously that varies some based on application, and we can give you further guidance on this. We've talked about it plenty in the past, so there's a lot online. When you add in thin provisioning, 5.5 goes up to in excess of 12 to 1 data reduction. We want to be very clear that thin provisioning is a dynamic form of provisioning. It does not reduce your data set. And I give you this visual example here that I shared at VMworld. Well, regardless of the size of my data, if I just keep making a thin provisioning run larger, my data reduction ratio goes up, but the actual capacity on flash doesn't change. So all we are asking, again, and having a more intelligent conversation in market, is you should never count thin provisioning numbers. And any vendor that can't separate thin provisioning from data reduction probably doesn't have a strong data reduction engine. So I put together this chart. And I know the storage industry loves comparative charts. Someone somewhere online right now just swore at me. You're welcome. But we believe this is a fair representation, and it is sourced from multiple public documents. And so what we are trying to show, and this is somewhat quantitative, that he who has more data reduction capabilities can drive greater storage savings, which are economic savings to customers, can make flash more affordable for more data sets and more types of applications. Dedupe doesn't work the same as compression. They don't have the same results in the same types of data sets. So whether we are looking at data reduction services, if they're always on or are they an option? Usually when they're optional, it means there's some performance trade-off. At the provisioning state, do you support thin provisioning and all the means to keep thin, whether it's zero removal, pattern removal, right, unmapping with T10 SCSI specs, right? These are cloning, like forward provisioning. I don't want to write data a second time if I'm going to provision from template, or if I have to make additional working sets for VDI or development use cases, etc. When I get into the actual compression and deduplication, am I doing this in line? And if so, what's my granularity? Where can I align? Where's my alignment boundaries? And what's the size of the granularity that I can have? Right? We've been very proud that our history starts with a 512 block geometry. We're probably the only vendor out there that could dedupe a 7.5 kilobyte, block. This is something that's unique to us. Or deduplicate across misaligned data file systems. But when you go past the inline, is what does your system do in terms of what's the boundary for the deduplication? Is it global, which means the more data I put in, the greater the data reduction numbers are? Or am I segmented by volumes or disk groups or RAID pools or whatever the terminology may be? Because if I have to segment my data reduction or run it on just subsets, I can never have the global efficiency or the efficiency that I can achieve on a global data set. And at a minimum, even if I have the same data, I still have to copy it twice because I have it in separate multiple volumes. Okay. Last but not least, and Neil didn't touch on this in significant depth, but inline compression has a trade-off between CPU cycles and the data reduction footprint. And so we do a very lightweight or mid-weight inline compression algorithm, as do most array vendors and application vendors that use compression. You're doing this to preserve performance of the system while reducing what we're ingesting. When we get to a time of background optimization on the array, such as garbage collection, and we have to move data, we will take that time, because it's not an inline operation, to actually apply a more aggressive form of the actual inline compression algorithm, as well as then follow it with a subsequent second encoding algorithm, so that we can either further the data reduction capabilities on the original data set, and or provide data reduction capabilities on data sets that we maybe were unable to compress initially. And this is to always drive with the customer additional savings over the long haul and reduce write amplification for the life cycle of the flash. Right? And then beyond this is then providing, we think, kind of a foundational piece, snapshots, replications, etc. Any thoughts, comments? What I will share with you is, when you start to look at block sizes, we believe that this really starts to show itself when you start to look at aged file systems. I was at another storage vendor in the virtualization space for many years before coming to Pure, and I've helped bring dedupe to market there. And we saw the effects of deduplication on misaligned VMs versus aligned. Right? How quickly putting, let's say, an AV file or an operating system patch out to two machines, one aligned and one misaligned, how the array couldn't deduplicate them because of that simple offset made at a block layer on the array, two different forms of data. Well, it's the same here as if my deduplication boundaries don't align with the file system size or the application size upstream, as file systems fragment then, so will that writing of that data to the array, so will your loss of the dedupe element of your data reduction capabilities. So, in closing, 2 slides. You saw this earlier on from Kix. We believe we're at a tipping point in market. We believe we've started this through economics, right? Make flash affordable, or we're not talking today. We thought we'd address enterprise scale and integration points. Otherwise, right, you can't replace disk systems because they're rather mature in the infrastructure. And then we redefined availability, right, and redefine what it means in terms of operations. And so the bottom two are very unique to the flash experience if you are a disk-based customer today. It is not a one-for-one transfer between just a faster form of medium. Going forward, and we've shared this in public format, so some of you may have seen this. This market was started around 2009, 2010 with a number of GA products from flash vendors who created the all-flash market. This was also the creation of the Tier 0 market. Not a large market, but the one that said your most demanding and critical apps need the performance of flash, where we all got the moniker in our heads of how many IOPS can flash deliver for me. Right? In 2012, Pure went GA with the flash array. And this was software to take and deliver the performance promise of the Tier 0 guys on a different economic curve, one that put flash at the price of disk. We're now in 2014. You've seen just about every enterprise array vendor enter the all-flash market and have entered with a promise of making flash affordable at the price of disk. Most of them start by retrofitting systems. When they figure out that that doesn't work well for the longevity of flash, they either build from scratch or acquire all-flash arrays. So we've seen the market, but it is saying that flash is the new Tier 1 form of storage. As you look at flash fabrication rates increasing, flash densities increasing per gigabyte, those two net out to be a reduction on a price per gigabyte of flash. And we feel that as we look 2 years forward, intellectual property on the software stack and the systems builders like Pure Storage, you will start to see Tier 2 storage economics come into the all-flash space. And this is a different conversation because this is more capacity focused, more where we're looking at what's my watt per gigabyte, how many gigabytes per rack unit, and how do we start to reverse the data center sprawl or the sprawl of data within the data center. That's it for us from Pure Storage today.